All right, kids, so there's three problems here. This will be a relatively quick video, I think. I hope. This first one's a no-brainer, right? If you have the -5, 10, and you reflect it over the x-axis, if you reflect over the x-axis, that means the y value is changing, right? And that would just be -5, -10. I don't think I need to talk about that one. Now here, if you're reflecting over a point, we talked about this earlier in the year briefly. When you're reflecting -5, 10 over this point essentially becomes the midpoint between -5, 10 and the other endpoint. So all you do is ask yourself, how do you get from -5 to -3? You add 2. So add 2 more, and that's a -1. From 10 to 1, you subtracted 9. Subtract 9. So this is like your one endpoint, and that's the other endpoint. That would be the midpoint. So that's pretty easy to do when you're reflecting over a point. You can just kind of count it out like that. You can use midpoint formula to help you if the numbers get ugly. Okay, now this next one, we're going to reflect this point. This one's a little bit more work. Okay. So remember, if we're going to reflect a point over this line, that's just like when we're doing distance. If you're measuring the distance from a point to a line, you would measure perpendicularly, right? Well, when you reflect over a line, you would reflect perpendicularly over it as well. So it's a lot of the same ideas here. So the perpendicular slope of this line, of course, would be -1/2. Okay? I'm going to try to do this without making an actual sketch. So our line, we're using this point here. The equation of that line would then be y minus 10 equals -1/2 times x plus 5. That's the perpendicular line. All right? That's the perpendicular line. Now, we're given y equals 2x. So if we solve this system, we would then find where these lines intersect. Now remember, that intersection is going to be the midpoint from this point to the reflected point. So if we know one endpoint and we have the midpoint, we can then find the other endpoint. So this solving the system, finding that point of intersection gives us the midpoint. So let's take this, stick it up in there, right? So we get, what does this become? It becomes 2x minus 10. I'm going to distribute. I don't like those 2's, so I'm going to multiply everything by 2. I don't like that. What I mean is I don't like those denominators. Let's just get rid of it. Okay. So then in the next step, we would have what? 4x minus 20 equals -x minus 5. 5x equals, what's that, 15. So x is 3. Now if x is 3, I can just plug in here, y is going to be 6. So we have a midpoint of 3, 6. Now listen, you can use the technique that we just did here in part B. -5, 10, that's an endpoint. This is the midpoint. The x's we're adding 8, so add 8 again, you're going to get 11. The y's, we started at 10, we went to 6, we went down 4. Sorry, I messed something up here. Yeah, no, that's right. So we would go down 4 and go down 4 more to get 2. But I'm going to show you mathematically if this way that if the numbers aren't always so nice. Remember, our point was -5, 10. Our midpoint is 3, 6. So we want to find the other endpoint, this. So we know that -5 plus this unknown x over 2 has to give us this 3. So then we just cross multiply and move and we get 11. You see? That's really not that bad, is it? And then for the other, we started at 10. We want to add this unknown y over, I'm just using midpoint formula. That has to equal 6. 10 plus y equals 12, so y equals 2. So our answer, again, we could have used the counting method like we did in part B earlier, is 11, 2. That's our reflected point. We found the midpoint. All right, that's it.